Hello, my name is Mr. Fontenot. Welcome to my YouTube page, Mr. Fontenot 1111. Please like, share, and subscribe. In this video, I'll be making the calculations for a parallel complex resistive capacitive circuit from the Chapter 17 math handout, problem number 25. I have filled in my known values from the Chapter 17 math handout, shown here. Let's unhighlight those because those are not the ones we're using now. And we're doing problem number 25, so you see the values here. And I have already clipped from the Chapter 17 formula handout the formulas that we will be needing to make these calculations. So the first thing I'm going to do, since voltage stays the same in a parallel circuit, I'm going to go ahead and fill in all of my voltage values. Alright, next I'm going to calculate my IC value by taking and using Ohm's law. We can use Ohm's law inside of these parentheses. So to find IC, I'm going to take my 100 volts divided by 25 ohms, gives me 4 amps. Next, I'm going to find my IR. 100 volts divided by 50 ohms gives me 2 amps. Notice I did not go ahead and find ZT using formula number 16. I did not do that because that formula is only for series complex. This is a parallel. Formula 16 cannot be used for parallel. Be careful not to make that mistake. It's very tempting to go ahead and try to find ZT because you have both of these values. But you can't do that because you can't use formula 16 with a parallel circuit. So we're going to find IC and IR first. Then we're going to find IT, and then we're going to find ZT. So to find IT, we're going to use the square root formula. Open square root, we're going to put in our IR of 2 amps squared plus 4 amps squared. And this gives us our total current of 4.47 amps. Now that we have that, we will use formula number 22 you see here to find our impedance. So we take 100 volts divided by 4.47 amps. And this gives us, our total impedance. So make sure that you follow that process. Now it's time to find our theta 1. So here we see that again we're going to do inverse tangent. So you got to do shift tangent. And we're going to punch in our current through our capacitor of 4 amps. Hit over under and 2 amps. Scroll over, close parentheses, hit equals, and it's 63.43 degrees. You cannot add IC and IR together to get IT because the current going through the resistor and the capacitor go through there at different times. They're out of phase. How much out of phase? 63.43 degrees. Alright, here's the answers I'm asked for on the Chapter 17 math handout Canvas answer sheet assignment. I've got my current. I've got my impedance. You don't have to type ohms. And for my theta 1, you do not have to type degrees. Just put the numerical value. Thank you. Hope this helps you.